Can you hear me? Thanks. Yeah, it's here to stalk me. Hey guys, my name is Biju. I'm from Bloomberg, working with a team which manages HBase and help some of the applications in Bloomberg adopt it and use it efficiently. The focus of today's talk is just to share some of the experience what we had by trying to build a multi-tenant cluster. So that's the bottom line. It's just going through the features and sharing some of the knowledge what we gained and how we can improve this. So this is the high-level outline. So I will try to go through the context or the motivation why we wanted to build an multi-tenant cluster, and then we will go through some of the features what is available in HBase, which would help to build a multi-tenant cluster, and then share the experience, what are the goods and the bads, and how we can improve going forward. So I don't know whether anybody has, other than the Bloomberg folks, anybody has experience looking at the Bloomberg terminal. This is just a snapshot of the different data which can be pulled up. Just very small snapshot, and the different UI presentation features here. It looks nice, but it hides a lot of details, the technical details about data acquisition from different sources, different types of data, how it is being stored, retrieved, and the different UI features which you can use to paint this different, what do you call it, the charts and everything. Some of the data points here. So behind this, we have like almost 19,000 people. And I was surprised to hear we have more reporters than some of the major news organizations in the US. So as you can imagine, the technology is, the big chunk of the people in our organization is technology people. And you can see some of the data points here. We just do 120 billion pieces of data. It's like more than 10 million messages per second. So what that mean is we have different data stores, and one thing which would come again and again is we should have this data available reliably, and it should be available for users with low latency. So that is always, if you talk to any Bloomberg folks, that's two criteria which we can't compromise on. The reason being that you don't want your 401k financial analyst not having the data as quick as possible. So that's the main reason here. In terms of HBase use, we started back in 0.94. Right now we are doing like almost more than 2 billion reads per day and 1 billion writes per day, and we have 51 terabytes of compressed data stored in HBase. It's purely from the production perspective. So I'll just walk back how we got here so that you know the motivation for why we are looking for to go into an multi-tenant cluster. So as with any organization, we started with having picking up a few good use cases which we can use or which fits very well with HBase. So what we did is for that use case to be successful, we created clusters, individual clusters for each one of them so that they are successful, and we know that HBase is a suitable platform we can use in our organization. So what that ended up in is creating like this. So you have multiple clusters managed by a bunch of people, and we got stretched at some point, and we start, okay, this is not the right way to go. So what we are thinking about is to have to consolidate this and have a larger cluster. So that's the goal. Even though it comes with its own challenges, the idea is that this will be much more efficient than having individual clusters for each application. So while we saw some success with the initial use cases, there were other products which they thought they can try to use HBase. And they said, okay, we have use cases which can be a write use case. Some of them said we have read use cases. Then we thought, okay, since we learned initially that we don't want individual clusters, we want to build shared clusters. But we went with flavored clusters, like we have a read-only clusters, we have write workload clusters, and we had some read-write clusters. So that was the mix of clusters we built. And we had these other applications starting using these clusters. And at some point, what happened is read clusters become, the same workload become read-write as well, because they start, okay, read is working fine, now let's try to do some writes. And the write side says, okay, now we are writing very well, and then let's start writing to do some reads. So that start happened, and we ended up in this kind of situation. Each cluster is being used, and then everybody was trying to steal resources from others, and whoever comes into the workload comes in, who comes in first, they just take over the resource. And if somebody makes a mistake, they just try to make a mess of the other people's use case as well. So what we are trying to do is make it much more streamlined. So we want to make sure that whatever the resource what we have, we want to make sure that it's divided appropriately and given to each tenant in the cluster. The last one is cost, right? So anybody heard this statement about MIPS and cost? Anybody had worked in an environment where your manager comes and says, our MIPS cost was so much, right? Yes. So right now, but you may say that's not it's a age of dinosaur, right? But there's another cost for it, right? The cost is in terms of power. So personally, I am very passionate about having less resource usage. And if you look at it, what I read is that a server may spend 500 to 1200 watt hour. So if I just took a hypothetical scenario, if you are spending, or if you are able to, if you are spending 550 watt hour, that converts into how much CO2 emissions and how much acres of forest you need to sequester it, right? So that's another thing which we can avoid. So if you are able to make it efficient, you can reduce the energy cost, and that in terms help the environment as well. So that all the motivations why we thought that we should go and see how we can build efficient HBase shared clusters. So what are the features to build an efficient shared cluster? The first is we want to know how we can define a tenant in a cluster. So what feature is available in HBase to define a tenant? So we already have it, and everybody knows it because it's by default available. It's a namespace. So what we can do is you can take a tenant and group every objects created for the tenant under a namespace, and you can control access between the tenants by using ACLs. Since this is a known component, I'm just trying to, for completeness, I have documented the ACLs and how to go about creating namespace in HBase, so that in future somebody wants to look at the slides, they should be able to figure it out. Once we have defined the logical grouping of a tenant, then the next one is to see how we can segregate or how we can define the resources for each of the tenants. So basically, in a cluster environment, the three main resources which we want to be able to define for each tenant is CPU, memory, and storage. So what features we have? So one of the features, just I think Stack touched upon, is the region server groups, and Francis biologically sitting near him that his team implemented the region server groups. So for the benefit of some of the folks who are here for the first time, let's review how does the allocation of resources work in HBase. So when a user creates a table, the HBase assigns a region server, and the data gets written into the region server. And as the data grows, the regions get split, and the master would say, now write all the rest of the data into different region servers, right? So it gets spread around. And the assignment is done by the balancer and the assignment manager we just heard about. The idea behind the region server group is to be able to define different regions servers into different groups, like yellow group or pink group or red groups, right? And also being able to say a table to use one of these groups, so that the storage, the resources for that group or the table is defined or will be used by the workload coming to the table would be confined to that region server group. So in this case, if the red table is defined to use only the region server group yellow, then all the data goes into that region server group, and the workload is partitioned that way. So that in this case, the CPU and the memory will be for that group will be used for that group will be using only the region server 1 and region server 7. Behind the scenes, this is how it's been implemented. What we had originally is we had a load balancer which would balance the regions across all the servers in the cluster. But by defining a region server group, we have added a filter by. So what that component does is it takes it gives a subset, a view of the region servers, so that only that region server and the table in the region servers will be assigned using the load balancer. So for example, if a table is defined to region server group 1 and the filter by would say, okay, any region which is created for that region server group has to use only these region servers, and that way the load balancer would say, okay, now go and get assigned to these region servers, and that way it is demarcated and the resources been divided across. And also endpoint has been implemented so that you can create the commands like the creation of the region server groups and the addition of table to the region server groups and deletion, whatnot and whatnot. It's done through the endpoint. So in order to enable the region server group, you would need to add these two properties and set the values at this point in time, and then restart the cluster so that the region server group is enabled. And what in turn it does is creating the region server group table. And then once the cluster is up and running, you can do addition of the region servers groups, and then you can assign the different region servers to that region server group. And if you want to assign a table, you can use the move command. And also, the region server group can be defined or set on a namespace level as well. So once we define the logical grouping of a tenant, then you can say this tenant, which uses this namespace, can be assigned to a certain region server group. One thing to note, though, in version before 2.0, there's no move server namespace group, and you need to, when you create it, you should set the names, the HBase RS group name to the corresponding region server group. So this is on a high level. You can divide the CPU and the memory, but it still leaves a wide open gap in terms of storage, because now if you are using HDFS, any tenant can be use all the, if they want to, they can use all the HDFS storage in that cluster. So for that, then we have a new feature called the space quota or the storage quota, which is officially out in 2.0. So what we thought is, okay, we will give it a try and see how that functions. Internally, this is how it works. A user can come and create a quota, and the quota gets stored in a new system table called HBase quota table. And what happens is, if the quota is set on a table or a namespace, the region servers would send a report. All the region servers will send a report to the master to say, for this table, this is the space is being used so far. And the master would consolidate all the statistics and then update the quota table again. Then there's a refreshing period in the region servers, which would pull the data out and say, okay, if this table has reached the quota or not. And if it has reached the quota, what it would do is, when future request comes, it would say you are above the quota, and then it will start enforcing the policy. So that's on a high level how it works. Again, to enable quota, you would set this property and set it to true. What would happen is, when you restart the cluster, it will create the quota table. And once the quota is enabled, you can use these commands to set the space quota. So you can set the space quota on the table level or the namespace level. And you have a bunch of policies. One is no inserts, which means after the policy is hit, there'll be no more inserts allowed on the table. And no writes is, it will allow the, on top of not only being able to write, it will not also allow you to delete. And the other two policies are no write compaction. That means it will not, on top of the no writes, it will not allow compactions as well. And then you can say disable. So that means you will be disabling the table. And if you want to reset the quota, then what you can say is the policy be none. So that way it resets the quota. For some reason, like for example, in development, you are dropping and recreating the table, and you want to set the quota to stay ever, And there's a property which you can say, the last one, the HBase quota remove on table delete to set to false, so that if you delete the table, it just stays there, so that you can reuse that policy. So this is using the region server groups. You can set the quota of the CPU and memory on a high level. But if you don't want to segregate the region servers into groups, but you want to still define some kind of quota for network or CPU, there's features available in HBase as well. It's pretty much by controlling the throttling of the traffic, it indirectly controls the amount of CPU used by used in the cluster. So the pattern is the same. You can create the quota, and it gets updated into the HBase quota table. But the only difference between this and the space quota is that the quota set is on each region server level. So if you set that for a table, you want to have 10 queries per second as the maximum, then if you have 100 region servers, then all the 100 region servers would look for that quota to be met before it throttles the queries coming in. So this is the set of commands you can set. You can set this quota on the table level, namespace level, and the user level as well. In the space quota, you'll not be able to set that on the user level. And if you want some user to bypass all the quota, then you can use the last command to do the global bypass to true. There are a few more quotas which is available, which you can use to segregate or define the resource usage in a cluster. The first one is the metadata quota. And I think based on our experiences, looks like it may be a good choice for in development. The metadata quota, the pattern is the same. The two types of quota you can set is number of tables to be created in a namespace and the number of regions which can be created in a namespace. There are the two set of namespace quota you can set. In the case of a number of tables, if you have a namespace and say you have 10 tables you can create in the namespace, if somebody tries to create a 11th one, the master would say it will not be able to do it further. But on the side of the region, number of regions in a namespace, what will happen is whenever the region gets bigger, the region server would try to split it, and the master would say it will not be able to split it. So there's a communication between the region server to the master in terms of the region quota. So this two quota is mainly on the namespace level. You can set the namespace, on the namespace you can set the maximum regions and the maximum tables, and then you can use the method of unset to unset this quota. The next one, which is available in HBase, is purely not on the from the tenant's perspective, but it's again gives us flexibility within the tenant. If the tenant wants to segregate between the call, the get versus read. If the workload is that it is more reads than writes, then you can set the queues for the reads more than the writes, and also you can set the queues number of queues for scans and gets, because scans are much larger, but you want still the gets to go forward. So you can set the quota on the scans and the gets. So these are all the properties you can set to define the request quota. What you can do is you can set number of request handlers, and then you can say how many queues you want to have per request handler, and then you can say the third point is about how much is the percentage of the queues you want to define for reads versus writes, and the last one would be you will be able to set the number of queues for gets versus scan. This is a percentage within the read queues what you have. So you have the total number of queues, you have read versus write queues, and within the read queue you can have get versus scan queues, the percentage. So after going through all this, then we started, okay, let's give it a try and see how it goes with the different features. So currently, the first case, what we were thinking about is, since we have some of the shared clusters, we can try to implement our groups and see how it goes. So for example, we want to see Currently, we have a 10 node cluster, and we want to define 2 tenants who has given budgets for 5 nodes each. So we can define 2 5 node clusters. And what would be the problem? So by testing, as you can intuitively understand, that when you have a larger cluster, you have more nodes to service the request. Even though sometimes they step on each other, more nodes to service the request. That means when you reduce the number of nodes in the cluster by defining the region server groups, you have less capacity to service. So just an example here, you can see just I picked up the write performance. When you have a region server group, then you would have latency is increasing or the write performance decreasing. It's not a HBase problem, it's an expectation problem. We want to go back and tell the tenants, guys, we are going to define region server groups, and you would expect, and how we want to mitigate it. It may be a conversation with the tenants to see how we want to mitigate this problem. The next one is data locality. We leverage data locality because we have, as I said, low latency is one of the requirements. So data locality is key for most of the use cases what we have. And with region server groups and HBase doesn't know HDFS favored nodes, what can happen is the data locality can go bad. So this is some of the statistics, and it was good to see that, because after I saw this data locality going low, searched for it, and then we had a presentation done last year in DataWorks. I think we talked about Yahoo had the similar situation where they have the data locality going low. And this is just kind of creating some chaotic situation between a cluster with all the nodes and a cluster with half the size with region server groups. What happens is we can see consistently in the region server groups, the data locality becomes bad. So again, we need to look at how we want to mitigate it. So this is how it should work. But I think we understand that there's a Jira ticket available. So as I said, when we have this issue, when we go to the tenant, they'll always be sad that we don't want this situation. But there is a ticket which is open for some time, which is 15531, which what does is it understands the favored nodes in HDFS. So what will happen is when HBase sends a write to HDFS, it will say use these as favored nodes, which is the nodes in HDFS which corresponds to that region servers. So some of the other factors we want to take in consideration is when you define the region server groups, you want to make sure that they are distributed across the racks, because we have a requirement that we should be able to bring down racks at a time so that we don't lose capacity. So we want to make sure that that's taken into account when we are building region server groups, so that they are spread across all the racks. Again, in terms of system tables, which is the HBase system tables and the Phoenix tables, system tables, you want to make sure that it is in a group which is large enough so that it can withstand failures, because they have to be in a region server group as well. So it can't move across the whole cluster. It has to be within that small region server group. One thing we noticed is if all the region servers in a region servers and region server groups goes down, and even if they come back up, the tables don't become available. So that means you would need to, for some reason, the master data is not getting reset. So it means you need to restart the HBase master. There was a question because we leverage region replication, and it requires that you need to have stochastic load balancer. But when what will happen is since region server groups in turn uses the default load balancer, we found out that it doesn't. It supports indirectly the region replication as well. So these are some of the things we figured out. And I said, altering. Okay, when in 1.x, if you go and alter a namespace and think that all the tables in the region server and the namespace would go to that region server group, it doesn't happen. So what you need to do is you need to explicitly move all the tables in that namespace to the region server group. In the latest code, which is 2.0 or 3.0, what we found is that if you bring down all the region servers down, which holds the system tables, region server in the region server group which holds the system table, then the cluster become unavailable. And if you're looking at, or if you're trying to go to test the region server group features, maybe these are further Jira tickets you may want to be aware of. Space quota. So I think just to recap what we found in space quota, you define the quota, then what happens is the region server send reports, and the master consolidates the reports and updates the quota table, and the region server has to read the data and then say, okay, whether the the table has reached the quota or not. So we want to figure it out, what is the impact of the delay between all this happening. So on a quick test, this is some statistics I produced. So the first two tests is like setting up 1 gig as the limit and just running some sequential write using the PE tool. And you can see that in the first case, it by the time it recognized that it is the limit has been reached, it is like 50 gig. The third one is like setting as 10 gig, and then it's a larger cluster, and you can see it became worse. It's like 160, 170 gigs, or 210 gigs. The last one we'll talk about, because there are some parameters you can tune or set it and see to reduce the time period for the whole process to happen. So that's something to play with. And these are all the properties. It is the property to send the report, or how often the region server has to refresh the data from the quota. So these are all the 3 properties you can set or reduce the time and see how it works. But the only problem is it means it would do the work quite often. That means your resource utilization on the region servers will be much higher. I think Josh pointed out there's a ticket out and it has got merged, which is 18.133. Right now, instead of setting this time, using the time to send this report and do the refresh, HBase would do these reports when there's a flush or a compaction, so that it will be much more current when region server looks at the data. So we haven't tested it yet. We'll be planning to test in the next week or so. So few more issues we found, which is like if you said, I talked about that you can set the limit to none to remove the quota and space quota on the table, but in the latest code doesn't seem to take an effect. And also there's a ticket open that if you disable it and then now go back, the table got disabled because the quota got reached, but we went back and then increased the quota, and we expected that to enable itself, but didn't happen either. So that's the as usual, HBase community jumps on any ticket and tries to fix as soon as possible. I think both of them have Jira tickets right now. Sorry, fixes for that right now. Something to be aware of on the metadata quota. One would expect you set the region size, number of regions to be 10, and if you say 10 gig for each region, and if it is 100 gig, it should stop writing into the table. So that would be the normal expectation. But what then happens is the last regions gets bigger and bigger. So it just keeps on writing. It doesn't stop writing at all. So just to be aware. So that's the point on that one. And there's some issues with when you define throttling quota or the RPC quota and the space quota. The space quota doesn't seem to, or the removal of the space quota and re-enablement seems to having some issues. And one of the contributors is looking at it right now. Okay, we tried. We thought, okay, since the quota, the space quota is taking so much time and it is not getting identified within a time period, we thought we'll try to set a HDFS quota on a namespace level and see what happens. And it just brings down the region server. So in summary, all the features what we want to build a multi-tenant cluster is there in HBase. You can set it on the higher level, like using region server groups with space quota, or if you don't have a large cluster to define on a higher level, you can use some of these throttling and space quota features to control the space usage or the resource usage. But still, as I mentioned, there are a few issues which need to be ironed out. And some of the improvements, I think as I talked about, HBase 15.531 would be a fantastic addition. The reason being that without that, we are losing some of the added advantage we have with a larger cluster, which is mainly, namely the data locality. And the next one is system table availability. Right now, we need to, with region server groups, we need to restrict ourselves to a smaller set of region servers to hold the system table. If we are able to move the system table across all the region server groups so that we still have the same kind of availability. Right now, if that say I have five region servers for the system tables to be held, if that goes down, the cluster is unavailable, even though you may have 50 region servers in the cluster. And one thing which may be good to add is right now, without the region server groups, we don't have any way to define memory quota for each region servers. So that's a good addition to have in HBase. Acknowledgements. I think some of the folks who have worked on these tickets are here. So thank you, and thank you in general to the HBase community. And any questions?
Regarding some of the other resources like the HMaster or Zookeeper, have you had to deal with any of that?
No.
No?
So far, no. But we are trying. We are still in a development environment where we are trying to get more knowledge on any major issues or gaining some administration experience on a development environment to see whether we see anything. But so far, none.
So have you tried using multi-val? Because for compliance and stuff, in a true multi-tenancy, we don't want the tenant's data to be written on same files. So have you done any testing on multi-vals?
Because right now, whichever we have the security-wise, if we have PII data or everything, we move it to a separate cluster in a separate network zone, a DMZ. So we never had to use multi-val in our environment. At least from the security perspective, we never had to use that. But that's a good point, though. We want to try it at some point and see what's the impact of it.
Can you please elaborate more on memory quotas?
It's like, so right now we can use throttling to say, you want to throttle this user to be able to only do so much per period, right? But right now, if you want to say, this table has to use this much amount of memory, we don't have that feature, like cache, for example, right? So if you say I want to restrict this tables to use this amount of memory, that's something which is not available. Does that make sense? Yes, and even yes, primarily on the cache, to say I want to be able to define a set of memory to be able to use for yes.
So could you explain how did you create these region server groups initially that you mentioned?
Sure.
And my second question was a follow-up question to the answer that you just gave to the gentleman about cache. So if I have a region server, let's say with 32 gigs of heap, and is there a way if I define a quotas for a table that it can only use certain memory from, or is that what you were talking about?
Yeah, that's not currently available. So that's one of the add-ons we can have that will be good. So in terms of defining the region server groups, as I said, we have to add a few properties in the site XML and restart the cluster, and then there are commands to say what so you can see that on the top, you can say, you create a new region server group, and then you can say, I want all these regions, the region servers, which is RS1 and RS2, to be moved to that region server group. Yeah.
But in terms of resource definition for that group, how do you do that?
Because the whole group the region server is allocated to that group. So there is nothing like you can go fine grain into it to say, I want so much of, no, it's like the whole region server goes to that group, yes.
For access control, you haven't discussed Ranger. Is that a reason?
No, we are not using Ranger.
You just haven't tried it?
We haven't tried it, I don't think.
Okay, I was just wondering whether there's a reason you didn't. Okay.
I mean, again, sorry. Just thinking ahead, I mean, how far are we from having preemption? So for example, like stuff that Yarn actually does. So if your tenant is inactive for a long while, do you just waste all your regions for that tenant? Because if I've assigned like, let's say 10 regions to a region group, and that tenant is not using it, I'm wasting my resources, right? So is there like auto scaling, or how far are we from like yarn-based?
I don't think there's anything like that. I think there was a vision there. I think I've seen some tickets that that's the way. I think Sean Busby, I don't know whether he's here, he has articulated one of the tickets about how we want to proceed further. That's how we started with some of the throttling and stuff like that, but we haven't gone so far yet.
Hi, how do you define the RPC throttling quotas for like each table or namespace? How do you come up with the number? And what happens if, I exceeds like 10 MB per second? And if I go up, would my application fail? Or do I have to come up with some exception, do I have to come up with something like upfront in my application so that if I hit that 10 MB per second, my job doesn't fail, something like that.
It wouldn't fail. I think it will not respond until that period is over, and then it will start responding back to the queries what is coming in.
Okay, so
From
the application side, like we don't need to do
it'll be slower.
Okay.
Yes, and also to come up with the numbers, I think we would need to look at your application and see how we want to allocate or how we want to define that quota across the different applications which is running on the cluster.
Okay.
How are you dealing with upgrades and lifecycle management with multiple tenants on one cluster? It's kind of hard to move the whole thing without getting everyone to buy in on it.
Yes, I think right now that's some of the challenges what we have. So we have to get buy-in and do that upgrade. And one point I wanted to talk about it is that with region server groups, you would be able to have different configurations. Correct me if I'm wrong, Francis. You should be able to have different configurations for different groups as well in different region servers. So that's one thing we will be looking forward to. But right now, we are in the same shape as you are. Like you would need to coordinate with all the tenants to get the whole cluster to be upgraded at some point in time. Yes. Yes, we have. Yes, you're right. Yeah, we have a second cluster. We always have an partner pair, so you would ask them to move to a different cluster, and then some of the times I think you would, if a rolling restart, you don't have to do it, but still we want on a safe side to be on the other side and then upgrade the cluster. Yes.
Yeah. So sorry, just one comment about the previous throttling exception. So I think in HBaseCon, throttling exception is a non-retrievable exception. So the client actually will fail. But we had a fix coming, I think I forgot the upstream JLA, but with that fix, there's an option to make the throttling exception as retrievable. So
Okay.
that's just minor correction.
Sorry.
So about throttling exception, right? The previous the person asked, it's actually a non-retrievable exception. So which means that the
It's a
HBase
one-point-
client
it's-
logic won't retry by itself. The exception will be slow up to the HBase client or the application code. So you need to handle specifically catch the specific application code needs to catch the specific throttling exception. So otherwise, the
It
job
will-
will fail.
Okay. Yeah. Okay.
Yeah, but we have a
It's-
fix. in
Okay.
recently committed. Sorry. Yeah.
Thanks.
Hi. How do you actually make sure that the tables go to the same region server group when you enable HBase replication to a DR cluster?
So
Is it already in place?
Yes, I think, again, the 15531, so I forgot to mention that that has got, so when it moves to the other side, the replication, right now, the replication doesn't recognize region server groups. So that's, again, thanks for asking the question. So that's one of the other items in the ticket as well. It's not only the favor nodes, then again, to make sure that the region server groups recognizes
Replication.
yeah, replication as well, yes.
Did you mention data locality was a problem when you created these groups? I
Data-
saw one of your slides that talks really bad data locality that you have over there. Is that how I read it? Is data locality a problem that when you create the region server groups, or?
No, yeah, I think it's not just region server groups. It's like region server groups at this point in time, it doesn't know the HDFS layer to be used or the HDFS nodes to be used. So that means the data the data will not be on the same node as the region server. It can be in a different node as well, because you have a smaller set of region servers, and then you have large number of data nodes. So it can the HDFS can spread the data around, so there's no locality. So reduced locality means you have the performance goes down as well.
So when I do a major compaction on that,
Yes, it should improve the yes, that's right. Yes, but I think if there's a failure which happens, then it all. So what I was trying to do in that picture is like, if even without failure, sometimes you can see the locality has reduced. The locality, like normally in a larger cluster, it gets 0. All the blocks are local, but in the case of when you define a smaller region server group, we haven't seen instances it may like 5% of the data blocks is not local. But if you try to kill region servers randomly, similar to what we had a bigger cluster, you can see consistently that the locality is bad than having a larger cluster. And that seems to be in sync with what Yahoo had seen their experience as well. So that's why they started working on to make region server group to be aware of the favor, the favor node, they pass in the favor node, so that they know the HDFS has to write data into that nodes, which is part of the region server group. Thank you.